Hey guys, this is Dustin, and welcome to the second episode in this Lua tutorial series. So, first off, I need to apologize. It's been a really long time, guys. My excuse is that university has been really tough. These past 2 quarters have been really tough. But I'm finally able to have some free time that I can spend and actually work on my YouTube channel. Summer's coming up soon, in just a couple months, or a month and a half. So I'll be able to put out a lot more content and actually get you guys some content. I have a lot of ideas and stuff that I want to do. But for today, what's on the agenda is we're going to be covering functions and we're going to be covering tables. Now, functions and tables are probably the most important aspects of Lua. And after you learn about them, you can basically do anything that you want. So, first things first, let's talk about what a function is. So, many times in our code, we want to be able to reproduce and have code that we can call at any moment and have it do something. So we want to be able to have code that we can reproduce and reuse. And oftentimes that code that we have will also have a result. For instance, let's say you want to add 2 numbers, right? Well, that function that adds 2 numbers has a result, and that result is called the return value, right? So we can define a function by using the keyword function in Lua. Alright, and then of course we have to name our function, so we're going to say my function. The next thing, we also need some parentheses right here. And then we have to end it, just like we would with an if statement. So now everything in here is a block of code, is a block of code that can be run multiple times, whenever you want, whenever we call this function. So for instance, let's print hello world. Alright, and then if we run this code, nothing's going to happen. This is where it would print something. It doesn't actually print anything because we haven't called this function. We haven't said that this code should run yet. Alright? So to actually get that code to run, we can say my function, and then we have parentheses. And then once we run it, you'll see that it says hello world. Now we can actually call this many times. Alright? And then it's going to print hello world many times. Now of course, inside here, we can actually have operations. We can make it do many different things. So, for instance, let's say we want to add a couple numbers. We can say add, and then inside here, we'll say A, and then comma B. So what these are arguments, right? These are the values that we pass into the function that we want this function to be able to use, right? So, for instance, we've actually done this in the past. So when we say print 1 and 2, what we're doing is we're passing in the values 1 and 2 into the print function. Alright, and of course it prints 1 and then 2. So, the thing about that though is that it copies the value. Alright, so if we have A is equal to 2, and then we pass A into the function, it copies that value. So when we change A, the value outside of here will stay exactly the same. So let's make this work. Let's say local A is equal to 2. Let's say B is equal to 100. Let's say add A, B. Alright, so now we're setting A to equal to 100, but if we go out here and we print A, we'll see that it's the value 2. It's because A gets copied in here, and this A is a local scope A. Just like we were talking about in the last video with if statements, this is a local scope. And the value A gets copied in, and when you change it, you're changing the copy and not the actual original value. Alright, so what happened? This isn't very useful though, because we're just sending values into this function, and then the function is just doing a bunch of stuff, but we're not getting a result. We want to know what the value of A plus B is. So that's what the return keyword is for. So we can say return A plus B. Alright? So now we can say C is equal to add A and B. And again, we've already done this. We said local input is equal to io.read. What io.read is it doesn't take in any values, but it does return values that the user types in. Alright? So we're passing in A and B into the function, and then we're getting the value C out of the function. And of course, A and C is going to be whatever A plus B is. Or C is going to be whatever A plus B is. So if we go down here and we print C, we should see 102. And we do see 102. Alright, so some cool things that functions can do. Functions can actually are called in Lua are called first class functions. what that means is that functions are actually values. So we can say add is equal to a function. So now we can call it exactly the same. If we run it, we'll still see 102. But what this does is it basically shows that functions are basically variables. They're values that you can store in variables. Alright? What you can also do is, let me change this back, pass in a function into a function. So I'm going to say I'm going to call this operate. Alright? And I'm going to say pass an A, B, and then operation. Now operation is going to be a function. Alright? Now we're going to say return operation A, B. So we're returning whatever the operation function returns. So we're calling operation, getting that value, and then returning that value from the operate function. So what we can say is local C is equal to operate. We're going to do 10, 42, and then we're going to create our own function right here. And we're going to say the function takes an A, B, and returns A plus B. And then we have to make sure to add an end statement right here. Alright, so what we did was we passed in this local function right here, and this function, notice this function doesn't have a name right here. It doesn't have a name, but it is being assigned to the operation variable because it's being passed into that slot. You see 10 right here is the first element in this function call, so 10 gets assigned to A. 42 is the second element, so 42 gets assigned to B. Now this function, here just a second, this function is in the third slot, so it gets assigned to operation. So we call that function with the variables A and B, and that gets passed into here, and then we return the addition of those two. So C should be the value 52, which it is. Now let's copy this. Let's do, let's just make C global. Alright, we're going to copy that, paste it here, and then instead of plus, we're going to make this a multiplication. So now we can see it's 52 and then 420. So yeah. Now a couple cool things that functions can do is that they can actually call themselves. So inside here, they can call them the operate function itself. And what this is called a recursive function. So let me give you an example. So we're going to create a factorial function. We're going to pass in a variable called number, or just number. Alright, so factorial functions, if you remember, basically in math, a factorial is just every number. So if you see an exclamation mark 5, in math that just means you multiply every number below 5 together. So it's 1 times 2 times 3 times 4 times 5, which is of course 120. So 120 is the factorial of 5. So to actually define this function, we can say first we want to check if number is equal to 0. Because the factorial of 0 is actually the value 1. I'm not sure why that is, but it just is. So we're going to say if number is equal to 0, then return the value 1. So the factorial of 0 is 1. Alright, otherwise, let's say else. Otherwise, if the number is not equal to 0, we want to return number, whatever number is, times the factorial of number minus 1. Alright, so let's call this and make sure this works. So we're going to say factorial, and we're going to call it with the value 5. So we're expecting this to be equal to 120. So if we call it, we'll see that it actually is 120. So what is this doing? So if number is equal to 0, it's just going to return the number 1. So if we pass in 0 right here, we're just going to get the number 1. Alright, so that's working. But if we pass in a value that's not 0, what it's going to do is going to return that number, so this number is going to be 5, but then it's going to call the factorial function with the number, which is 5, remember, minus 1. So we're going to go back up here, and now number is equal to 4. Number is not equal to 0, so it's going to go down here, so now it's going to be 4 times the factorial of 4 minus 1, which is 3. It's going to go back up. Now number's 3. Number's still not equal to 0. It's going to do this pattern until number is equal to 0. Once it is, it's going to return the number 1. So now this will be replaced with 1. Alright? And that's going to return that. And that's going to be replaced with 2, 3, 4. And it's going to unwind what we call the stack. And then multiply all those numbers together. And then we're going to get a result. Alright. So what you can also do is you can actually have functions within functions. So we can say my outer function. And we're going to make a local variable, my local. Now remember, my local is confined to the scope. Meaning if we try to print my local out here, it's going to be nil. Even if we call my outer function, it's going to stay nil. Because when this function goes, when the block of code goes to the end, so it's going to start up here, it's going to go clear down here, it's going to get rid of all the local variables. Alright, so my local is confined to my outer function. Actually, let's leave that call here. So we're going to call it. So we can actually have a local function with inside here. So we're going to make this local. So we're going to say local function, and we're going to name it my inner function. And what my inner function is going to do is going to say print. It's going to print my local, and then it's going to append the argument. So arg, or let's just say ending. So we're going to say it's going to append whatever ending is, and we're expecting ending to be a string. Right? So now right here we can call my inner function, and we can pass in a value. So we're going to pass in the class, the string world. Alright? So now if we run this, we're going to see hello world. Because what's happening is we're passing in the string world. It's being assigned to the local variable, the local argument here, ending. Right? Now my local is not inside my inner function. I mean, it's exposed to my inner function's inner scope. Just like we did with an if statement. If you remember, if we had nested if statements like this. If you remember, A is accessible right here. We could print A, and this will print 1 right here. It's the same concept. It's consistent throughout Lua. So my local is actually available right here. But if we try to say local other is equal to ending, if we try printing other, we're going to get nil, because other is not accessible outside this function. So why would you ever want a internal function and not just put it out here? Well, there's a couple reasons. A few reasons is it's sometimes a good idea to keep your functions within a single place, so that if you have an API, an application programming interface, other users don't get to see that. And of course you can make it local, but sometimes functions are only useful inside that function. Also, a lot of times you want to have reproducible code that has full access to the outer variables out here. So if you have to call my inner function many times, then you probably want to put it inside that scope, so you don't have to pass in a ton of variables into the function. So the last concept I want to talk to you about functions is something called purity. So a couple good things, a couple things that you want to keep in mind about functions is that they should not be arbitrary. Functions should have a defined task that they're supposed to do. Alright, so you want to have a function do a certain thing, and you want the name of the function to describe what it's going to do. Also, you want your functions to be as pure as possible. So what do I mean by purity? Purity in programming is where, like, basically you confine variables to a certain location. So I can have this outer variable, right? I'm going to set it equal to 0. Now, if I go inside this function, I can access outer variable. I can say outer var is equal to outer var plus 1. And then let me return outer var. Now I'm going to print my outer function a couple times. Alright, so each time I print this, I'm getting a different result, even though I'm not passing in any value. So purity basically says that we want to keep our functions as mathematically based as possible. So in math, you pass in a single argument and you get, or you pass in an argument and you get the same result every single time, right? But every single time we call this function with the same type of argument, right, which is nothing, we're getting a different result. And that's because it's reaching outside the function and accessing a variable. So if we want to keep this function pure, we should have a parameter, right, that we pass in. So now if we call this function, we pass in outer bar, and we're going to get the exact same result every single time. And this is important because let's say you're debugging your code and your function isn't behaving the way you expect. Well, this can be really frustrating to debug because if the function is reaching outside and having different results because of different situations that your program's in, then it's really hard to reproduce and find out exactly what logic error your functions are having. So it's usually a really good idea to keep your functions as pure as possible. Of course, it's really hard to have 100% purity, especially in Lua, but it's something to strive towards. Okay, so the last thing we're going to be covering in this episode are tables. Now, we're not going to be covering the whole everything about tables because there's a lot to cover, but we'll go into detail later and really dig into what tables are and what makes them so awesome. But for now, I'm just going to give you a surface level explanation of what they are. So tables are something that makes Lua very unique. They're basically the way that we can describe data and map data. Alright, so what a table is it's basically a collection of variables. You can think of it as a collection of variables in a single variable. Alright, so let's define a table. So we're going to say my table of numbers. Alright, and we're going to have two curly braces right here. And we're just put some numbers. Alright, so now we have a table of numbers. And if you're used to other languages, right now this table basically behaves just like an array, except there's a few interesting properties. So we have a big list of numbers. Those aren't exactly useful unless we can access those numbers and check what elements are inside that table. Alright, so to do that, you'll use the square bracket operator. Alright, so you have a square bracket, opening square bracket, and then the index into the table. So which element do you want to access? So I want to access the first element. And I'm actually going to change the first element to something really distinct, like 99. So I'm going to access the first element right there, and I'm going to print out what the value is. So if I run this, we'll see that the value is 99. Alright? So we're accessing the first element in this array, in this table or array. Alright? So you can think of a table as a collection of, you know, my analogy of the box, how a variable is a box that contains a value. Well, an array is a box of boxes, right? That you can store variables or store values into each slot in the table. So we can access the first element, we can access the second element, which is 2. You'll see that 1, 2, the second element is 2. We can access the third element, which should be 6. You can also set the elements. So we're going to set the first index to 42, the meaning of life. And then we're going to print it right here. So I'm going to change this to the first index and then the first index. Now if I run it, we're going to get 99. Then we change it, and then we're going to get, then it's 42 now. Alright. So what if we want to loop through every single element in this table? So to do that, we have to know what the length of the table is. And to do that, there is an operator. There's the length operator, which is just a pound sign. So if you have a pound sign, and then you have the table name afterwards, we're going to get the length of the table, which should be 1, 2, 3, 4, 5, 6, which it is. So we get 6. So now that we know the length, we can say for I is equal to 1. Now we want to go to the length of the table. We're going to do. Alright? So if you remember we how for loops work, we just basically, whoops, let me, if we do this and then print I, this for loop is going to loop 10 times from 1 to 10, and it's going to increment I. So we print this, we're going to get 1 through 10. Let me remove this up here. 1 through 10. Alright? So if we get the length of the table right here, we're going to go through every single element of the table. Now if we print this again, it's going to go 1, 2, 3, 4, 5 through 6. Now we can actually use I as an index into the table. So we're going to say table of numbers, and we're going to use I as the index right here. And we're going to see 99, 2, 6, 2, 72, and 124. Alright, so that's pretty cool. Now what we can also do is go from 0 to 1 minus the number of the table of numbers length. Now if we do this, we're going to get nil in the first index, because arrays or tables in Lua start at the index 1. If you try to access a value that you haven't assigned a value to in a table, you're going to get back null, just like you would if you tried to read from a variable that hasn't been defined. But let's make this right again. We can actually have expressions in here. So we can say I plus 1, and we're going to start from basically 1 and then go to the end of the table. So that's how we can use tables as basically arrays, just lists. Now what you can also do, just a second. I had my caps lock on there for a second, sorry. What you can also do is just have an empty array, and we can insert values into the table. So of course we can say, let's actually have our, let's actually print all the values in the table, and then let's try removing all the values. So this is of course is going to be 0, and let's actually change this back to 1. Just like that. So we're not going to print anything because there's no values in the table, and if we add a value to the table, we print it, we're going to get that value. Alright, so we can actually say my table of numbers, 1 is equal to 10, 2 is equal to 20, 3, let's be a rebel, or let's do 3, and say 60. Now we can say 10, 20, 60. So that's one way you can add values to a table. You can also push elements onto the table, or insert elements, and we can use a function that is defined by Lua called table.insert. Now the first parameter of the function is going to be the table, and the second is the value you want to insert. So 1238, sure. Now if we print this, we're going to get the value 1238 from there. And we can actually paste this a couple times, and we can see that they all get added to the table. Now of course we can add things different than numbers. We can add strings. We can even add functions. And it'll all behave the same. And you can see that I'll print it out function and then hello. So that's really cool. But tables in Lua are actually so much more powerful than just that, because they can also be used as key value maps. Now what does that mean? So let's say we have a table, right here, and let's say we want to use a string to index a table. So we can say table my value is equal to 45. Alright? So now if we print the length of the table, you'll actually see something weird. It's 0. But obviously we put a value into the table. So tables are separated into two separate lists. Right, so you have lists of key value pairs. So you have a key, which is this string right here. That's a key, which is mapped to a value, just like a variable name is mapped to a value. So my value is mapped to the value 45, right? So you have a list of those, but you also have a list of just random values. All right, so you can say 1, 2, 3. All right, then you can also say let's 1, 2, 2. Then you say hello 123. So you'll actually see that the list is equal to 3 elements because it's 1, 2, 3. But then this is also a key value pair. So if we run this, you'll see 3. But we can also print table hello, and you'll see that we're going to get 1, 2, 3. All right. Another shorthand for this is to remove the quotation marks and then also the square brackets, and this will still work. We're going to get 123. And actually, you can even do it right here. So you can replace the square brackets with just a dot. So you say table dot hello, then we print it, we're going to get 123 again. Alright, so this allows us to build up structures. Alright, so what kind of structures can we build? So let's say we wanted to find a 2D point in space. So the 2D point can be a table, and it can have an x value. We're going to set it to 10. Then it can also have a y value. Let's set it to 42. So now we can say point.x is equal to point.x plus 1, and now if we print it, the value that we should see is 11. If we print it, we're going to see 11. So you can have points be defined by an x and y value, and a bunch of other stuff. Now you can also do some crazy stuff like have arrays within arrays, or tables within tables, sorry. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so now you have a table within a table. This is often referred to as a two-dimensional table or a two-dimensional array. So how do we get, let's say, this index right here? How do we access the 5? Well, we just say table at index. Well, let's see, it's 1, 2. So it's the second array. So it's 1, 2. So it's the second array, or it's the second table. Sorry, you can use the words basically interchangeably in a lot of ways. It's the second array, but it's the second element. So 1, 2. So we're going to say 2 again. Now if we run this, we're going to see 5. We got access to the number 5. So if we want to get 6, it's the second element. So it's the second table. So 1, 2. And it's 1, 2, 3. So 6 would be 2, and then 3. So why are two-dimensional arrays so cool? Well, let's say you want to have a you want to simulate a game of tic-tac-toe. Now you can imagine these being, let's say 0 represents a 0, and then 1 represents an x. All right, so you can represent a board by a two-dimensional array of tables, and then you can get the use these as coordinates. You can think of this as the y coordinates, then the x coordinates. So the y coordinates would be up and down, right? And then the x coordinate is like left and right. So you can say, so this coordinate right here would be 3, 3, because it's 3 elements down and then 3 elements to the right. So you can have tables within tables. Now there's so many awesome things that you can do with tables, and we'll go into detail about how tables work in a later video just dedicated to them. But for now, there's the basic understanding of how to use a table and some of the things you could do with them. I hope you enjoyed this episode. Please let me know what you want to see next time. I'm thinking about talking about the standard library of code that you have access to. I'm thinking about going into detail about, well, of course, tables and stuff like that. And then also maybe some string manipulation functions. And then later on, even past that, we're going to go into more advanced stuff like meta tables and the cool stuff you can do with those. But yeah, thanks for watching, and I'll see you in the next episode. Hopefully within the next few days. Alright, thank you guys.